So everyone, welcome to, it's 11 but it's technically 10 because we have technical issues for number 10, so that's why you'll see one missing in the videos. This week's stream, kind of going back to the roots a little bit more. Like the last one we did a walkthrough of the ThoughtWorks Tech Radar, but we thought we'd change it up a little bit and get back to like doing some coding stuff. So this has been a long time coming stream where I wanted to try out state machines. I remember hearing about state machines when I was in university and people talking about them and like the benefits and all that kind of stuff, but I never really dug in it too much. Then it was maybe 4 or 5 years ago, I was at ReactiveConf, and it probably was the year it was in Bratislava, in Europe, and there was a talk from a guy, I don't know his actual name, but I know his Twitter handle. It's David K. Piano. So he gave this talk about using state machines in a Reactful application, and obviously he was, advertising his library XState, which did this for you in React. But as he'll admit himself, state machines have existed through the whole time of software development, and they're not a new thing, but it's how we can use a state machine to drive interactions in your application. So without further ado, let's get everything set up. So what I'd like to do is, like, it's funny enough, I had the idea of building the example of a traffic light system, because a traffic light system kind of can allow you to do a stateful application, because it can't be red and green at the same time. It has to be either red or green or amber. So that makes really good sense. And turned out there was a little bit of an example on the XState website, so I'm going to be kind of using that. So let me just grab my examples. Hopefully we can get going. So I'd already kind of built out a little bit of a dummy application for this. So let's jump over here without hopefully causing infinite loop. So we have our traffic lights application, and this is like our perfect example for doing stateful interactions. So I just thought of it there now. Need a sip of wine first. I think I could quickly hack this together in just raw React state, so we kind of have a use case of where we're coming from and where we're going to be going to. So let's jump in. So the code at the minute is just bare bones the visuals, and the visuals are done using Chakra UI, which is the last stream was meant to be about. So we have this app that has a stack, which is a Chakra, I think I'm saying that right, Chakra UI component. Then we have a heading with our traffic lights, we have our lights component, another heading for controls, and then our walk controls component. So if we look into our lights, that camera's going to be shaking like mad when I type, so apologies if it starts jittering about. So inside of our lights component, very, very basic here. We've got 3 buttons, a little bit of border radius on them, different colors. So we can add some state to this, but I imagine our walking controls are going to interact with this, so we'll raise our state up a level and put them in the app component. So hopefully get this done in a quick, dirty way of bringing in a couple of use states. So we can do const, I'm going to say is green. Now this is purposely going to be done bad so that we can show the benefit of using a state machine. So keep on doing a capital R, and I can't type. So the wine is kicking on already. So we can say false by default, and then we're going to duplicate this again and again. So we can say is green, is yellow, I say yellow. Some people say amber. I don't know if that's an English thing or American thing. And then is red. Obviously, this is when you see all come together again, like you wouldn't do it this way. And what you would end up doing actually is probably creating sort of like a state machine. So now we have these properties. So is it green? Is it red? Is it yellow? And we can pass them to lights. And grab multiple cursors. We also need to set functions too, because we want to really set. There do we? Now we can create one function up here. I don't want to pass down all of them. Const on light change, and we'll do to light, and we'll say to light. Oh, we could go even more hacky here. I don't want to confuse too much, but there's like, I was going to do like a switch statement and say like, if the light that been changed into was green, then we call the set as green. If the light that changed into is yellow, we call the set as yellow. But because we have the colors as a constant, we could do a hacky way of doing this, but we would never do this. So then we could say, oh no, can we? No, we can't. Fuck it, I'll just do this. Right. Case. And then our break. So yellow, and it's going to be set as yellow. WebStorm just takes a bit to catch up. Oh, that should be is. And then we do red for the last. Go on, red, and then this is going to be red. So we got a question in the chat. Is null okay to use in your option? In general, what was I reading recently? I was reading an article recently, and it was discussing defaulting values and changing values. Null, like maybe it's too basic, but null should be only used when you are creating a value but you don't want to set it. So you're saying this is null. Undefined is usually when something doesn't have a value that should have a value, if that helps or makes sense. So like, and then, but I think the annoyance with JavaScript is when we come into the idea of like a falsy value. So false is false, null is false, undefined is false, 0 is false, and empty string is false. So if I do so, yeah. Which, makes things complicated because you can run in cases. Thanks for joining, Bill. Anyway, you can check it out on the. I'll be uploading the video later in the week anyway, so you can catch up on the recording then. Yeah, so like this is where JavaScript really kind of fucks you over, where you have these multiple values that can be false, which makes it really hard if like you have an array, if you have an array of booleans or an attribute that is meant to be a boolean, but sometimes it could end up being undefined or null. Then, and you want to say like, you did like, I don't know, did this person commit the murder? It's going to be false on an innocent person, but it's going to be null. It could be null on a dead person because there's no way they could possibly have done it. I know it's a really weird example. But then you're having to say like, is the value actually, is it equal to, is the value false, not null? Is it false and not a false value? But yeah, right. So we've got our onLight change function that takes what the light we're moving to, and then we'll call the set function that. So we can pass that to our lights, and so we'll say on change equals that. So now we need to grab these attributes, make sure that they are props in here. Nope, did that wrong. I have like rainbow brackets, which makes it even harder to see which bracket I'm on, but it's meant to make it easier, and maybe I'm just not used to it. So we'll say disabled, because that should gray out the button a little bit. So disabled, let's see, just to put that on to see what it renders. I don't want it to gray it, I want it to kind of dull out the color for me. So it's compiling. Yeah, that's perfect. Takes away a bit of it. So we then want to say like, okay, disabled equals not is green. Disabled equals not is yellow. And then disabled equals not is red. Then we want our on change. So we're going to say on click. Now this is dirty, hacky, cheap code, but it'll work for us. So I'm just passing test in here. So this is going to be green, yellow, and then lastly red. And they match up with our switch statement. Yeah, so now technically they should all be disabled by default. Yep. And then if I click, shit, you can't click it disabled. Arch biscuits. Can you not? Yeah, the disabled because we don't click. Right, we need to do something else to make it dulled out a bit. I think we can do border radius or something on these. Right, we're gonna take the disabled off for now. Yeah, that kind of has caught me out. So there they are. Oh, why don't we try and find some sort of CSS we can add to make it like more distinct. I think they have a bit of drop shadow. Do they? Let's see. Is it drop shadow? If anyone knows how to use CSS, let me know. Let's see, CSS drop shadow or box shadow. Okay. I don't know. I never used W3 Schools. Find CSS tricks. We'll give you something. Okay, so we'll fire this on and see what this does. Once if I try and increase some of these numbers, what will it do for me? Yeah, that makes it look like it's highlighted or it's active. So so we'll create a shadow. not with all those new like characters. Yeah, so we've got our shadow, and then we'll say, so Chakra gives us some APIs to tap into the like the styling of elements. So let's see what we can do. It's a tasty wine. So we go box, yeah, box shadow, and then we would say is green, and add our shadow. Perfect. So just replicate that to all of these. Hopefully this works. Is yellow and is red. Let's see what this does. Okay, none. We're green. I don't know. It did put it on. Doesn't really make much of a difference though. Oh, that's the focus. Increase the size. Right. So I have a link to Chakra here. Oh, if I can get into Trello. I'm going to log back into it. Yeah, fuck it. Chakra UI. So I want to see what the size is. Could we make the size bigger? That would be better. So there's a 6XL. That's font sizes. How big can we go? Perfect way to find this out is use the React DevTools to inspect the component. So we can grab our button and we can say, so that's XXX. Nope. So I need to get what the size system is in Chakra. It's one thing I've struggled with these kind of libraries. Like they always give you an example where like you can use this size, but it doesn't tell you what the possible. Okay, so there's a possible. So MD. LG. Okay, so we'll do the size then. Right. So I'm going to say size is green. LG. Yep. Or MD. Copy and paste, copy and paste. Let's get this quickly. This is just to show the stateful way, which actually is quite simple and quick, but we have an example. 4x state at least anyway. And if there's any questions or people wondering on the stream like what's going on, like hit me up, let me know. I can try and answer questions. WebStorm is complaining here, but I don't think it's anything I need to care about. Yes, it is. So that shouldn't be ampersand ampersand. That should be a question mark because this is a ternary operator. Okay, yeah. So the small now. If I click on this, it gets bigger. Yeah. So we have some way to indicate state. We can go green, amber, red. However, I can click on that and that. And what if I mess up? Oh yeah, actually, yeah, I did it. I messed up. They're all active at the same time, which shouldn't be. So the quick fix for that would be in our app where we call these. You would then say so you would set this to be false, which would wipe them clean. So we let that refresh. So if I go amber to green, then that gets disabled. But if I go red to green, it's not doing it, because we need to maintain that cleanup in every function, which is the tricky and hard part. Just double checking the stream's going here. Okay. Yep, looks to be fine. So this is where Xstate is going to come in and help us out, because we don't have to manage this. We don't have to tell where it's going, where it's coming from. We have these multiple state items where realistically we only need one bit of state to say which is the current light active. So I need to go, I'm going to go to the Xstate docs. So we got all that out of the way. So go to xstate.js.org. We're going to go to docs, I think. So we're more concerned with the React plugin, but we'll take a look at like what it basically is made of. So is this starter for this different? No, it's very simple. In essence, you have like this, you create a machine because it's a state machine. Then you pass it like an ID, whatever the initial state is, and then the states that it can possibly be in. So for a toggle switch, you have two states, active, inactive. We have here, but you also have the initial state. Then you have this idea like on each state there is like, I want to call them transitions. I haven't read into this too much. I've only kind of skimmed the top of it. So yeah, once you define your state machine, you then create an instance of it. So using the interpret function, then you can say on transitions, you can log out, which is very useful because then you can capture, potentially feed off to an API and document how your state machine works, so you can do monitoring and seeing what states are being transitioned from. And then as well, then you have the ability to then like send messages. I would call it sending messages or sending state changes to the machine. And when I say state, this is not the state of React state. This is the like state machine state, if that made any sense. But yeah, you can do asynchronous states as well, which is quite cool. We're going to stay very low key. One thing I do really like about this is they have like this really cool visualization tool, so you can like add in a state machine, so like lay out all your states, but then you also get this like interactive like, I don't know, UML style diagram. So we can say like, you're in idle, then you fetch, you go to loading, and you have two options from here. You can either resolve or reject. So if you resolve, you go to success. So then we reset this because you can't go back. Success, you can't come back to resolve or loading from success. You need to restart your state machine. So you say idle, loading, or we click fetch, do loading, choose reject, we get failure. We can click on retry and we go back to loading. And that's how you make like continuous machines. So we can kind of see what the state looks like. So we have our idle state where we're not doing anything. Then we say on fetch. So we've sent the fetch state to it. Then that's going to go to the loading state. The loading state then has an on, so you can either go resolve or reject. It has so then resolve calls success, and it says it's final, which is interesting. So there's types. Or reject calls failure. Failure has an on of retry. It says it's loading. Action assigns retries. Oh, so you can even keep, I don't want to say state inside of it, where you can say, it has so many retries. It's quite interesting. But I think for this example, we're going to rip off the documentation and we're going to build out their traffic light system, and to kind of have a look at what we're working with. Let's pull this into is that also yeah, pull this into the visualization tool. I think that's, I just copy and pasted the same thing. Let's grab the docs. So light machine, update. Yep. Okay, so we got it. So we've got our green timer, yellow timer, red timer, back to green. Start with this now. In the UK, our traffic lights they'll go green, yellow, red, but then they'll also go red, yellow, green to allow you that kind of, it's no longer red and get ready to go kind of way. So we might try that. I don't know how to do, because then technically, you can only go from yellow to green if you came from red, and you can only go from yellow to red if you came from green. That could be a little bit more advanced. If there's anyone who's worked with state machines on the stream who knows like what the way to say, like based on the previous state that you came from, where you went to, if there's a way to get like the state history and an assert on that, could be quite interesting. But in our case, let's get set up to do our state machine interactions using React, because that's what we're coding with. So kill the terminal, fire our npm install command. So we need to import the utilities first. So we need our machine, which comes from the core of the library, and then get simple paths, which comes from graph. I don't know if we need that yet. Get shortest paths as well as another API. So let's see how they're doing that. Logging it out. So I'm wondering where this fits into the React model part. Because this is all just dealing with, oh shit, I'm in the wrong package. This is the graphs. I want the React docs. Oops. So, click the wrong one. I'm assuming, yeah, we need XState React. So, okay. Drunk mistake number one. Clicked on the wrong link. Thanks to everyone else who's joined in and watching live. If there are any questions about what the stream's about, what I'm doing, anything about development, drinking, and dyslexia, fire away questions in the chat. Check the chat's still going. Yep. That's some tart wine. So yeah. Okay, this looks a little bit more simpler. So we import the machine from React, import machine from XState, and then we create a machine, and then we call the use machine hook. Okay, which is not too bad. So again, we want to replicate this logic into ours, so we'll copy the imports, and we'll be doing this at the app level because I have a feeling we're gonna want to pass the state down, and we might try out this walk controls logic, but we'll see how it goes from there. So pulling these imports. And then we want to create our toggle machine. We're going to just copy, paste a lot of this, and then pull that in afterwards. So is that? Yeah, that's outside of our component. And then we want our pre-packaged traffic lights. So, yep, we got our traffic lights. We'll just call it light machine. We'll pull in the whole thing, copy and paste. Best way to do it. So, yeah, so we've got our machine here, and then we want to use the hook for this inside here. So now we can get rid of these 3 use states, which we should not need. This is going to call the light machine. And so now you can see that we have like our state and our send. So what is our state? So let this refresh. Oh, it would help if I started again. So we need to just start up React up again. Gives me time to top up my drink. And ensure everything is streaming. Okay, so we deleted some values that we didn't put back in place. Got someone saying should try recall. Seen a great luncheon learn today and work about recall. It's on my list to dig into. I think it's promising. I don't know if it's going to throw up a lot of issues with like people who just got the grips with Redux. You know, it's going to make these all true. Whenever React started, you know, everything had its own state management library. And I did fall into using a pattern of one that then got, you know, they end the life the state management library. At this point now, I'm like, you know, use built-in React context and React state. If you're using React context, there's a simple stateful provider, a nice little utility that I built. It probably won't come up in a Google search. So if I do, yeah. Oh, it has to be, oh, I'll go to my username and I'll get the package. So I created this simple wrapper called Simple Stateful Provider. So if we can find it, yeah. So it allows you to, there's 2 of them because there's a typo in the fucking name, but it allows you to create context and state really quickly and really easily, and then allow you to implement that anywhere in your application using like the under the hood React context. It comes with React 16, I want to say. So it's definitely something to look into and check out. So, right, where were we? So we've got our traffic lights on the go. So we can't interact with them yet, but I wanted to see what does our state machine, so our state is a lot of shit. Value is probably what we care about, green. So we know what our value is. So let's go back. Let's go back to our app, and we want to say pass in what the current light color is. So current light equals state dot value, and then in here again, then we can say, you know, current light and then for all these we want to say current light equals green, current light equals yellow, current light equals red. I was just actually thinking about that recall comment. It's funny enough, when I think of XState, I don't think of XState as like a state management tool. I think it's more of a state pattern. Like technically you could probably, you know, place your X state inside of the context, because it's using hooks. At the minute you can do context and you can say like use reducer and then place that inside the context, and then you're using like a redux style pattern. What's to say you couldn't use the use machine and then place that inside your context, and then you have a state machine inside a context, so you don't have to do prop drill and all that kind of stuff. And that's why I kind of think it's more of a pattern of how to maintain state, not a manager of the state. Whereas like recoil and context and redux and like alt.js and flux capacitor, they're all more state managers and not state management patterns, if that is not too abstract. So they're all small because none of them have been selected. So then we also have this send function. So we check our docs for what we do with send. Send triggers the event, which is going to be toggle, which for us is going to be timer. So we could probably wrap this up. I'll say on light change send timer. I guess we need a button for this, don't we? No, we don't need a button. We need something that steps over the lights. I want them to just change automatically themselves. So we're gonna say use effect and create a set timeout. So const change timer equals set timeout. Will be set interval. So set interval, and we're going to give it 1 second. I think that is. So every 1 second it'll change. Do we need to do use effect? Yeah, because we want this to start whenever it's completed. So by default, you're going to be null based on our original talk earlier about time, about null values. Then we'll do use effect, so it'll wait for the component did mount event, which I know doesn't exist with the hooks, but you know, that's the way it is. So as if you see me looking on the side, I'm keeping an eye on the chat, make sure I'm not ignoring anyone. So we can actually, this is going to be a let, and we're going to say change timer equals set interval, and then we do return clear interval change timer, even though this won't unmount unless we kill the app or whatever. 1M in timer. I'm going to fix that because that little squiggly line is going to drive me up the fucking wall. So yeah, okay, we've created an interval. It's going to go through and call our timer function for us. So we don't actually need to pass it on change down to all these. I wonder if this will work. That seemed like too easy to work. We haven't got any errors, but we haven't got anything changing. So you pass in variant color to the button component. Variant color must be blah blah blah. Okay, so something shit in the bed under the hood with chakra. So we've done something. Current light. Yep, these need to be capitalized. I think. Oh, what am I doing? I'm creating notes. What? Fucking multi-cursor. Yeah, is that the case? Is it going to be just a case of uppercase? No, that made things even worse. invalid transformation state for node dot light dot green. They need to be uppercase too. Let's run this. Oh, it gets worse. Initial state green, not found on light. Ah, Jesus. Why did I just make everything cap uppercase? Or would it be easy to make it my code lowercase to match this? That's far too quick. But kind of cool. And this is the moment where I realized I didn't click the record button. Or did I? No, that's counting up. Okay, so maybe we're recording. Okay, so we need to obviously make that a little bit longer. I'll go for maybe 5 on this. Yeah, so it's going to cycle through. But like, is that it? We created ooh, can we change the timeline? Right, actually, we're going to make this a little bit longer. And then we're going to say whenever it's red, don't walk will change to walk. Yeah, we can do that. So actually, what am I doing? We don't need state. So we can say can walk equals what do we call state dot value equals red. And we'll say what do we call this? Can walk so can walk, we'll print out walk, and then else don't walk. So what do we get? Walk. Let's do some color changes on this as well, just for the fun. Color black. Oh, it's gonna be variant color gray. Why can't they just call background color? I don't get it. So can walk, and we're gonna say so you can walk is gonna be green. If you can't walk, it's gonna be red. This is gonna probably kill the text. No, okay, it's not too bad. So, but then there is this whole idea of you can have nested state hierarchies, and then says, well, that's how they use the walk, wait, and then stop. So, I kind of we've got a little bit of time left. I kind of want to have a glimpse at this to see where we could go from here. So now we have this idea of pedestrian states. The initial is walk. I always thought the initial would have been wait. So initially you're not walking. Then it has its own states. So it has the state of walk and wait. And then so on walk you can go to wait, and on wait you can go to stop. And then stop has nothing. So when you're in stop you can't do anything. Oh, because you've crossed the street. So this is actually like taking the state machine like property, like you are a pedestrian, you've waited, you've walked. Oh, I don't know, you walk, wait, and then stop. Okay. Yeah, so to like drop these in, you just create it as another attribute on your state. We say current state is yellow, next state. So I'm transition current state timer dot value. And we can call these, yeah, so then you're able to call like the nested updates. Did they give a good example here? Because we just get the send. So send is a function that sends events to the running service. How do we send nested in this? They've probably done it here for me. We just need to scroll down. Assuming they're going to be the same. So in this case, we're saying like, all right, our current state is yellow. Then we say next, so we get the next state, or we transition to the next state. No, we get the next state. Then we say transition, red dot walk, call the transition, and then dot value. Let's see. So what do they call? I wanted to go quick Google search. So they're called nested. Is it nested machines or nested state? Yeah, nested state machines. Let's see if anyone else has examples for this. Or maybe we can just call it. So let's pull it into the visualization tool. Let's see what it thinks. So we pull this into our visualizer. Update it. Yeah, so then our state and our events. So we can send timer, send timer, send, and then we have pedestrian timer, send, pedestrian timer, send, timer, send. Oh, so right, if we go back to our red state, touching the mic, I'm getting used to this new setup, so things may be weird and awkward. When we're in the red state, we have two like event types that we can send. We can send our ped timer, which is our pedestrian timer, or we can send timer. So like this would be, there's no pedestrians there, send timer, and that takes me to green, because if we look at our definition, timer is green, but we've spread in this. So let's see. Yeah, let's add this in. Instead of our timer to do our movements, I'm going to add in a button that is going to trigger the events for us. Hopefully. Let's see, let's drop this in. So we now have our pedestrian set up, and we can get rid of our time-based scenario, and then we're going to have a dirty button, and that's going to be timer and ped underscore timer. I'm doing double M's for timer. This is 1M. 1M. Need add on clicks event for these. So both going to call send, both going to pass the string. This one's going to be timer, and this one's going to be ped underscore timer. ER. think this should also work. So let's see what we're left with. Yeah, so if I call timer, goes to yellow, timer, should have went to red, click timer again. Oh, maybe our values changed. Let's keep logging out our actual state object. Trick in WebStorm, do state dot log, then tab. Yeah, console logs it for you. So timer. Weird that it calls twice is like making me think it's either it's double rendering for some reason, whether that's me or whether that's something else going on. So our value is yellow. Timer. Our value is the object, red, walk. So let's distill this down. Oh, we're going to do a bit of hackiness here, because I want just the color to pass into those lights, and then our walk can define other things. So let's say let light color equals, right, I'm not going to try and one line this, so we say if state dot value, so we're going to say actually if type of state dot value equals object. That's not the best way to do it, but it'll work for now. Light color equals state dot value. Actually, no, we'll just say red, because we know it only happens on red. Else light. Oop. What the fuck? Where are we? Else light color equals state dot value. I guess we can do let can walk. We'll do walk state actually, and then we'll say walk state equals, so our state value dot red, yeah, which is weird. I wish it was like nested state or something. I guess it knows it's on the red. So now light color is passed in here as our current color, and then we'll do something with what color in a minute. So let's clear this out. So timer. Then our walk state actually has text in it, or we know what it is. But so if I go, oh yeah, because we're logging our things out, we can see what it is. So I can say timer. We're now on red with walk. Pet timer. We're now on red wait. Pet timer. We're now on red stop, and then we go timer to green. So we can grab our walk state and pass this in as a child. Actually, we'll make it a little bit cleaner. Again, any questions on the stream, fire away. If I'm doing shit that doesn't make sense. So children, and we're just going to go gray, go back to gray, or white. We'll go gray. Text color black, large button, and then this is now going to be children instead. which is nothing by default. So we maybe put some, well, we'll leave it, because when it's in green, well, that should be, the default is walk when you're in red. These all, because there isn't a value by default. Technically that should be wait as well. I don't know if that's part of the state machine or just part of the actual design logic of the application. So timer, and I said we can walk because it's in a red light. But wait, because we're going to leave, stop. And timer, we're in the green. So I guess we did take a React application that had 3 use state variables that could all happen at the same time, which isn't great. Convert that to a state machine where you can only be in one state at a particular time, as we can see in our traffic light scenario. You can't be in red and yellow at the same time, or yellow and red at the same time. We also had a look at nested state machines, so we'll be able to like have another state. Let's see, look at our visualization. Have another state underneath one of your actual states, which is quite useful. Like in this, the traffic scenario really gives a good idea of that, because you have that, like, you know, on red lights you can walk, so another state can happen while the main state machine is paused. I assume like you could go infinite levels deep on these state machines. You probably don't want to go too heavy on it because it'll get really hard to maintain and manage and understand, but being able to follow that is quite useful. I think the one thing that I like about this kind of state machine approach is the fact that you can tell where you came from, where you're going to, and what your possible options are. And it's not this, you know, Kensey Dodds did a brilliant blog post recently talking about this idea of, you know, you shouldn't have an is loading flag. Because what most people do is they say you need to fetch a list of users. You'll have users list initialized as an empty array, and then you'll have an is loading users Boolean flag initializes true. Then you fetch your users on mount, set the array, and then disable the loading flag. Now that's fine. You're going to end up replicating a lot of data all over the place. But then what if you have different states? So you have a state of fetching users, but you also have a state of modifying users. So fetching users, it's a spinner over the entire screen. Modifying users, there's a spinner over the top of the table. Should you be able to be in the fetching and the changing state at the same time? Probably not. But because you use multiple state objects or multiple state values that are independent of each other, you can be in that state at the same time. As the example we had at the start, where if I had created a is green, is yellow, is red state properties, I can set them all true, which breaks the rules of traffic lights. You can't have all lights true. You can only have one light on at a time. So having a state machine for these kind of interactions makes really good sense. There's been a few different examples I've been working with recently where a state machine could drive really well what you're conveying. So some examples could be, a modal that allows you to add an asset, but also edit an asset. Technically, it can only be either adding or editing. You can do things like if the asset has an ID or an identifier, then you're in editing mode. But that makes a lot of assumptions on your data, and it makes a lot of assumptions on your users, and a lot of assumptions on the developers who are going to work on it, that they'll understand that pattern. But if you use the state machine, there can only be two states: adding, editing. So you can't be in both at the same time. If you go on the route of a Boolean flag, you could set is adding true and is editing true at the same time, or back to back. Or what if you add on is moving, is deleting? then you need to make sure that you clean up and you manage all those different possible state values. And it's having those multiple variants of the same state and being able to control them. This is where a state machine comes really strong into play. So kind of ended up on the stream. I think definitely go check out XState. The docs are really cool. They've got patterns for most libraries as far as I understand. Yeah, we've got Vue, React. Yeah, that's the only thing people are using. The visualizer is great because it allows you to build out your state machine and actually test and work through it, because you can look at the state values, look at your events, and like iterate through them and play and test. And I don't know what they're for, but like you can like replay and edit. It's a really interactive way of working with your application state, so you can reason and you can understand that state in a very adaptable, common way. So this was my version of using XState, building a traffic light system that allows you to do traffic lights and have nested states. Okay, kill the recording. Thank you.